boot camp, right? Boot camp sounds like a really tough word, but we're going to spend some time together. We're going to go through some concepts that you've probably learned before, or maybe you haven't learned yet, right? Depending on where you are, what grade level you're in, and you probably want some clarity. You have a lot of questions. And so you've come to the right place. So let's go ahead and get into it because I don't want to use all your time. And I'm also going to share with you some proven study habits, study skills that are going to help to improve your grades, improve your studying as you prepare for not just like final exams or SATs or BGCSEs or BJCs, but that can help you now if you implement those things. Okay. Now my voice is kind of a little raspy and I'm a little nervous because I've had a long day of teaching, and I thought that I would be more energized for this, but either way, I'm excited and I'm looking forward to our time together. So here we go. All right, so here we go. So what I want you to do, for those of you who are live, and also those of you who are watching the rebroadcast, I want you to type in the chat where you're tuning in from. And if you want, you can include your school name as well. And when I go through the call, I might just shout you out, or I just want to know where you're tuning in from, and that will be really great, okay? So here we go. I do have like a little disclaimer for you, which pretty much is something that I want you to be aware of. All right, so here it says the information shared is solely for educational purposes. So what does that mean? Well, pretty much I can share with you all kinds of things, but I can't force you to do the work. I can't force you to put in the effort to help you to get the grades or help you to understand the concepts. These are things that you're going to have to, on your own, really decide, okay, do I want to do this? Do I not, right? But I can give you the ball and you can decide how you want to play with it, right? You can decide what you want to do with it. You can decide whether you want to give it back or if you want to play ball, okay? But I'm going to just give you some tips and tools. And another part of it is when I teach something and I teach you a strategy, it's not a matter of right or wrong. It's not a matter of better or worse. It's just giving you options so you know what you have available and you can try and see if it works, okay? And so with that being said, why are we here? Why are we here? Well, we're here because we say, okay, we need help. We've probably tried different things. We've gone to afternoon classes. We've taken these exams over and over and over again. And we're at a place where we're like, okay, let's try another option. And so here is another option for you for the next 4 weeks, and Sundays and Tuesdays at 5 o'clock. So we have 8 sessions together for free. And the only thing you have to be willing to give up or to give or to invest is your time. And your energy and your desire to say, okay, I'm going to try this. I'm going to practice. I'm going to put some of these skills to the work or to the test, okay? So make sure you do that, all right? So before we do that, I'm going to do a little bit of an exercise. And the exercise is like for a mindset. Now, you might be thinking, why are we doing a mindset exercise and we're supposed to be learning how to solve equations? Well, for the most part, if your mindset is in a different place or if we're not aware of how we're thinking, it can impact how we do or how we absorb the information that's being given, right? So let's take a look at the exercise. Now, what I'm going to do is I'm going to go ahead and I'm going to show you what it looks like. So I want you to make sure that you move to a quiet area. So when you're studying and you're trying to learn something new or focus on something, the best practice is to find a place that's quiet or at least that has minimal noise as possible so that you can focus and your mind can really, really pay attention and absorb whatever it is you're learning. So go to a quiet place, okay? And this is for whether you're live or you're just watching it at another time when you can actually go to a quiet place. And then next thing you're going to do is grab a piece of paper. And now for the next few slides, I'm going to show you a series of words. And I want you to tell me, and you can write number 1, 2, or 3, or 4, how these words make you feel. All right. Now I have a series of 4 emotions, and there's obviously more emotions than the 4 I have here, but I want you to choose of the 4 how these words make you feel. Now, if there's an emotion that is not here, but you feel really strongly that this is how you feel about this word, you can type it in the chat. Okay. And that should be good. So the first emotion, number 1, is confident. Like you're like, oh man, I can do anything. You know, I am the master I'm the pilot of my own plane or my own ship. I can do all things. The number 2 is sadness. or disappointed, right? Now, keep in mind, there's a couple of words coming, so you're just going to describe how you feel about those words, but I want to go through the emotions that I'm wanting you to think about right now, all right? And then number 3 says you're indifferent. Indifferent is like, I really don't care. I don't care if I pass. I don't care if I fail. I don't care what the grades are. I'm over it, okay? And if you're there, then, that's where you are, and that's okay for now. And then the last one is confused. Like, I really don't know what they're talking about. I'm so lost, and I just want to run away. That's sometimes how people feel when they are confused, like they want to run away. But so tell me how you feel, okay? So the first word is school. How does school make you feel? Do you feel confident, like I'm at the top of my class, I'm at the top of my game, I'm good, and I'm extremely excited about it? Or are you disappointed? Are you sad? Do you feel like, man, I wish I could do better? My grades are not where I want them to be. I like my friends, I enjoy my friends, but I wish it was better. The other part is number 3, I don't really care anymore. In other words, I've gotten to a place where if I get an F, I get an F. If I get an A, I get an A. It doesn't matter. And then confused is most of the things that I hear while I'm there, I don't understand. And if that's where you are, then that's where you are. Okay? So school. And you're going to write that down on your piece of paper. All right? So what about the next word? Exams. How does exams make you feel? Well, while you're thinking about that, for me at the time, exams made me feel kind of nervous, very nervous, and sometimes disappointed. Sometimes disappointed, especially depending on the exam I was doing. If I didn't understand the content, if I wasn't prepared, even more so, I was more nervous because I didn't know how I would do. And so let's take a look at the next word, okay? The next word is math. Ooh, Some people are like, oh man, that's a curse word. I don't want to hear the word math when I come home or when I'm chilling. But how does math make you feel? Like, do you feel confident when you step into math class? Do you feel excited when you're about to get back your grade? Or do you feel disappointed? Do you feel like, oh, I just don't care anymore? I've tried and I don't understand it and whatever. Do you feel confused, right? Are those things that you feel? And if they are, I just want you to acknowledge them. Write them on your piece of paper next to all of the other feelings you have about the other words we've kind of looked at already. And then the other word is this, teachers. How do you feel about your teachers? Now, there might be a specific set of teachers or a specific teacher that you can think of that you're like, okay, this teacher specifically, I can't. Or there might be a teacher that you're like, I really love most of my teachers or all of my teachers. I want you to think about, how do your teachers make you feel? Now, you can have multiple emotions because you have different teachers. So you can say, okay, Miss So-and-so makes me feel like this. Mr. So-and-so makes me feel like that. And I want you just to acknowledge how you feel, okay? And then let's get to the point. Like, what's the point of acknowledging or being aware of how these things make me feel, right? Are we getting graded on feelings? No, you're not. But being aware of how you feel does help you when you're navigating, like, just about going to study or just wanting to succeed, right? So here's the point of all of this, right? At the end of the day, it says, I am not going to let how I feel stop me from being successful or stop me from doing the best I can do, all right? So your feelings, they're valid. That's how you feel. But I want you to know that feeling disappointed and feeling sad and feeling confused, I don't want you to let that get in the way of you actually succeeding and doing well, because you can. All right. If someone told you couldn't, I'm telling you, Miss Nelson is telling you that you can be successful, you can succeed, and I believe in you. Okay. Now, let's keep going. All right. So with this mindset exercise, whenever you are about to step into an exam or step into a math class or whatever class you feel like you hate to the core of your bones, I want you to think about something. So sometimes we say school is boring, right? And that's all we dwell on, is that school is boring, school is boring, school is boring. There's something else better I can do. I want you to say to yourself, I am going to work hard so that I can afford an enjoyable life, okay? In other words, I'm going to work hard here so that I can enjoy my life later, all right? So I don't have to live a boring life as well as be bored in school. All right. So I want you to adopt a different kind of habit or approach to when negative thoughts come to your mind. What's another thing or another thought that you may have, and how can you combat that thought? Well, you might say exams are hard. And I have a 2-year-old, 3-year-old now. And I remember she would say, Mommy, this is hard. This is hard. And I would say to her, and I would call her name, and I would say, I want you to repeat after me. Say, I, and she would say, I can do hard things. I can do hard things. And I would always tell her that, like, you can do hard things. And when I see her doing things that I would say for her age are difficult or hard, I would say, look, baby, you're doing hard things. And so I want to tell you, and even now she would come up to me and say, Mommy, I'm doing hard things. And I'm like, yes, you are. And yes, you can. And so for the students that are like watching me and listening to me, you can do hard things and you can do them well, whether you like it or not. Okay. So I want you to know that that's what I believe. And if you repeat that to yourself long enough, eventually I'm hoping you believe it, that you can do hard things and you can do it well. And so as a math teacher telling you this, it might be like, well, I've tried math and it's hard. Well, you can do hard things and I'm here to show you how and how to do them well and to the best of your ability. Okay, so let's keep going. Let's say you say that math is difficult. Difficult things make me strong. Okay, I want you to, when you feel like, oh, this is so hard, this is difficult, I can't do it, say that difficult things make me strong. And sometimes what that might mean is you might need a little help, and that's okay. It's okay to have help to do difficult things. But the point is, we're not trying to do everything that's easy. When you're doing everything that's easy, you build no muscle. You build no muscle. And at the end of it all, you're not quite satisfied, or you don't really know exactly how much you can do. So difficult things make you strong. And if you think math is difficult, I'm telling you that it might be difficult, but we can do difficult things and we can be successful at it. And so I'm here to help you on that journey, okay? Now, like I said, I can't force it on you to be successful, but I know it's inside of you. And so we're trying to pull that out and show you what already exists in there, okay? And then the last thing, I hate my teacher. If you feel that way, like I absolutely hate my teacher, then I want you to think to yourself, I will pass her class or I will pass his class so I don't have to take it again next year. Okay, at least you'll see them a lot less if you pass than if you don't. Okay, so let's not dwell on the negativity. Let's just think about, okay, how can I overcome this and how can I move forward? All right, so how is our time together going to go? How is this boot camp going to work? Well, here it goes. First, we're going to do a mindset exercise every time, all right? Or some kind of exercise to get ourselves geared up for what we're going to learn. And so that's what we just did. And the reason is because negativity and criticism are the enemies of success. So if we're always negative, always criticizing ourselves or other people, success is not the end goal, okay? So let's kind of just keep that in mind. The next thing is I'm going to go into reteaching 1 or 2 basic math concepts that will enhance your understanding. Now, for the first 2 weeks, we're going to do a lot of foundational stuff that you may feel like is elementary and you already know. And the reason I'm doing that is because I'm talking to a lot of students. All of the students that I'm going to be talking to or that are going to be watching this, they're in a whole, they cover a range, right? So I want to make sure that we're all caught up. So when I use different languages and I do different things in the other sections of our time together, we're not all lost, okay? Now, the beautiful thing about a recording is you can listen to it again. And so the next part is I'm going to give you an exam prep tip. Now there's 8 weeks or 8 sessions. So every session I'm going to give you one that I want you to put into practice as soon as possible. Now remember, it's not just for exams. It's for success, period. These are scientifically proven strategies that people use to succeed in exams, to improve their grades. And I believe that if you implement these like right away, don't hesitate, you can get really good results as well. And then lastly, I want to make sure you have some resources. Okay, how do I find practice questions? How do I find good videos to watch to help me when I'm lost and I'm confused? I'm going to make sure you have that, okay? So let's get into it. Okay, so what are national examinations and standardized tests? Now, for some of you, you wonder, okay, I'm preparing for an SAT. I'm preparing for a BJC or a BGCSE. Why do I have to do this? Well, generally speaking, our society, every society runs on systems, okay? They have a system for everything. For example, whether it's water running to your house, how is electricity wired from one house to the next? There's systems. And so when it comes to examinations or testing, how the overall culture or the overall nation is doing in terms of education, standardized tests or national examinations is a way in which they measure that. So we can sit around all day and complain about doing them. But as we know, complaining, negativity, criticism does not lead to success. So I'm not here to say whether they're right or whether they're wrong. I'm here to say, if you're going to do them, let's prepare and let's do well. Okay. So let's keep going. What are we going to talk about this evening or during the time or whenever you're watching this? It could be morning, evening, night. It doesn't matter. We're going to talk about 3 things. I don't know if we're going to get to the 3rd thing because I don't want to be long with you. But I want to talk about vocabulary first. So we're going to start with expressions, and we're going to talk about vocabulary and then simplifying expressions. And then lastly, evaluating expressions we're probably going to get to on Tuesday. All right, Tuesday at 5 o'clock. Now, the beautiful thing about being live is that if you ask a question or if you type something in the chat, I can see it and I can respond to you. So if you're a student, you're watching this, whether you're watching it live or you're watching it after, type your questions in the chat, okay? And I'll do my best to make sure I respond to you whenever, if it's at the, watching it later when we're not live, I'll try to respond when I come on the next time. Or if it is live, I'll try to make sure I respond as soon as possible during the live call. But let's talk about vocabulary a little bit. Now, I know there's a lot of topics to cover for these exams. And so, it's 8 sessions. There's only so much we can cover. So I'm going to start here and then go from here. Now, with that being said, vocabulary. Now, math can be beautiful when you understand it. Vocabulary is one of the building blocks of math. In other words, when I say something, what do I mean? If I tell you to go to your cabinet or your cupboard or whatever you want to call it, and I say, I want you to get the white thing, and you go to that cupboard and you're like, Mom, what white thing? Well, you'll be a little confused. Why? Because I wasn't specific. I didn't say I want the white can of tuna with a certain label on it. And so that gives you more of an idea of exactly what you're going for and exactly what you need to do. Well, in math, we like vocabulary because the thing is, we're not going to tell you every step. Instead, we're going to give you maybe 1 or 2 words, and we're saying those 1 or 2 words will summarize everything we want you to do with whatever's in front of you. And so vocabulary is going to be very important. So I'm going to use a lot of definitions while we're together, and I want you to pay attention to it, because as I go on with the next, maybe I call 5 or 6, I'm going to be using these vocabulary words, and I want you to know what I'm talking about. Okay, so let's get into a little bit of vocabulary when it comes to expressions. All right, so here we go. I have an example in front of you of an expression. This is just an example, which means that there's other ways or other kinds of expressions or other ways expressions can be represented. This is just an example. All right. So I want to talk to you about the different kinds of an expression, and then I'm going to give you a definition of the expression altogether. Okay. So you understand what we're talking about and how to identify an expression versus maybe something else that you're looking at. So the first thing, and I have some vocabulary words below, okay? And if you can't see, you can just zoom in your screen. So the first word is a variable. And I have the definition. It says the value that changes in an expression or equation. And specifically, if you want like the, straight to the point definition of a variable, when someone says, what are the variables or name the variables in this equation or expression, what they're talking about are the letters, okay? In other words, X and Y. Now, X and Y, they're letters, but later on when you do like evaluating expressions, we're going to ask you to change out the X for a number instead. Okay, so in other words, X can be represented as any number we choose in the future, and we'll talk about that. But for now, I want you to consider or just think about the fact that a variable is just the letter, okay? So if I say, what variables, or name the variables in this expression, I just want you to say, what letters are there, all right? So I don't want you to be confused about what am I talking about when I say in a variable, all right? So now, next one, a constant. What do I mean by constant? Well, it is the value that does not change in an expression or equation. Something easier or a way to identify your constant is just looking for the number without any variable, okay? Without any letters attached to it. So the constant in this expression is 5, all right? Now, next, what is the next thing? So we have in front of us the coefficient. All right. Now, the coefficient is the value that is attached to the variable by multiplication. That's very important when I say by multiplication. Now, I'm going to show you what the coefficient is, and then I want to talk to you about what I mean when I say attached by multiplication. All right. So the coefficient is the number 2. Okay. Now, how do I know? I don't see a multiplication sign. I see a 2 and I see an X. Well, whenever we have a number that's attached to a variable and there's no explicit operation, in other words, there's no addition between them, there's no subtraction between them, there's no division between the coefficient and the variable, then the assumed operation is going to be multiplication. So multiply. Now, 2 is the coefficient. It is the number in front of the variable and it's attached by multiplication. And the way I know that is because there's no other operation explicitly stated there. So whenever we have that, the assumed operation is multiplication. All right. So let's keep going. The last thing is a term. What do I mean when I say name the terms in this expression or name the terms in this equation? What do I mean? When I say terms, and you can look at the definition here, it says the combination of constants, coefficients, and variables separated by explicit operations. When I say explicit, I mean it's like literally in your face. Okay, I can see the plus sign, I can see the division, I can see the subtraction, all right? I can see the parentheses. That's what I mean when I say explicit, I can see them. But notice, like I said, when I mentioned about being a coefficient, there is no operation in between them. It's literally 2x. So if I was naming the terms here, one of the ways I can name the term is by looking at all of the operations that I'm dealing with, and I can use those as separations between the terms. So for example, there's a subtraction sign here and there's an addition sign there. Okay. So if I were to name the terms in this expression or count the terms, I would have one term here, one term here, and another term here, right? Now, if I were to identify those terms individually, the signs matter, okay? The sign that is in front of the term matters. So if I'm going to name these terms, the first term would be 2x. The second term would be negative y, because remember the sign matters. The reason I didn't put a plus sign in front of the 2x to show that it's positive is because I don't have to. The only time I need to indicate that it's positive is if it actually matters in terms of telling the difference between whether it's positive or negative. The y, I have to put the negative sign because if I don't, the assumption is that it's positive and it's not. And then the last term is a positive 5. All right, so there we go. So this is your definitions, and these are the words I'm going to be using during our time together: variables, constants, coefficients, and terms. All right, so let's look at some other examples of some expressions. All right, so here are other ways you can, or other representations of expressions. They can look different, right? So for example, we have an expression here that has a square on it. We have an expression here that has division involved, and this one here that has parentheses, right? So it can look different ways. And even this is an expression, but it just has one term in it. Okay, so let's keep going. So that's all the vocabulary words for now, and those are the words that I'm going to be using, and I just want you to be familiar with. And the good thing is, because it's recorded, just rewind if you didn't catch some of the terms or some of the definitions or vocabulary words, and kind of familiarize yourself with it. One way that you can remember vocabulary words is using flashcards. On one side of the flashcard, put the word. On the other side, put the example and the definition of the word. All right, so let's keep going. Now, we talked about vocabulary when it comes to expressions. Now I want you to look at simplifying expressions. Okay, so we simplify expressions a number of ways. Now, the ways that we're going to talk about are by combining like terms, using distributive property, and using order of operations. Okay, now I will say this, I don't want to be on our live like too long, because the reality is this: eventually when you start falling asleep, you become ineffective as someone who's studying, okay? So if you ever find yourself falling asleep, what you're gonna do is you're gonna pause the video. You're gonna go take a 5 to 10 minute break, and the part of that break might be you want to exercise, you want to get something to drink, you want to just take a little walk, you want to go outside and breathe a little bit, and come back. All right. So I want to give you some bite sizes just to chew on, apply those things, and then come on back, and we're gonna build on top of what we've learned. So now, simplifying expressions. We got the vocabulary out of the way, and now we're gonna simplify. And what do I mean by simplify? Well, there's 3 ways we tackle simplifying expressions. One is combining like terms. The other one is distributive property. Another one is order of operations. And there are other ones out there, but these are the 3 that we're going to tackle as we go forward, all right? Now, I want you to consider for a second as we go into the combining of like terms. I want to do something or talk about something that's relatable to you, okay? Now, while I was doing this, I was trying to figure out what is something that everybody has in their house or everyone can say I own something of. When I was younger and we started talking about combining like terms in school, they used to talk about marbles. And I wondered, do kids even use marbles these days? do people play with marbles anymore? And I don't really know. So one of the things or something that I thought everyone probably can relate to is clothes. All right. So everyone should have some clothes somewhere, hopefully. And if you don't, just use something you do have. But clothes. So imagine someone comes in with a hamper full of clothes and they say to you, okay, I want you to, sort these clothes out. I want you to put the pants in one section and the hats in one section and the shirts in one section. How do you do that? Well, let's take a look. I sorted them for us. All right. So we have all these hats, we have the shirts, and we have the pants. And for the most part, depending on how organized you like to be, you'll probably go ahead and put all the shirts in one drawer and the pants in one drawer. And then some of us like everything just in the same drawer and we'll just dig through it to find what we want. But in math, we love to sort as well. And we use expressions and we use terms as tools for sorting. All right. So in math, like I said, we love to sort also. We don't like things all over the place. We like things in order. And so what does that mean? Well, usually what we'll do is, in order to sort in math, we'll take something like a hat. Let's say the group of hats that we have here, right? And we'll say, okay, I'm going to use, so we have all these hats here, and we say, okay, I'm going to use a variable to represent the hats. So X is the variable I'm going to use to represent all the hats that I have in my in my ownership or my hamper. And then they'll say, okay, perfect. So all of the hats, I'm going to use the letter X or the variable X to represent. And then they'll do the same thing for everything else, but they'll give them different variables or different letters. So for all of the shirts I have, I'm going to use the variable Y. And then for all of the pants, I'm going to use the variable Z, all right? And honestly, X, Y, Z, you can use any letter, it does not matter. But X is very popular and Y very popular. It's just a habit. So either way, you can use any letter you want. But let's keep on going and see how we sort in math, okay? Okay, so now if you take a look at this, we already established that, okay, we're going to use X for the hats. But now it's not enough just to use X to represent the hats. We also want to know how many hats we're dealing with, right? We're not just dealing with any number of hats. We're dealing with a specific number of hats. And in this case, we're dealing with 5 hats. I hope I count. Yep, 5 hats. And so what we'll say is, okay, if X represents hats, then I have 5 X's or 5 hats. All right, so 5X represents the 5 hats that we have. And similarly, the same thing applies for the shirts. I have shirts and they're represented by the letter Y or the variable Y. And so I count the number of shirts I have, and I happen to have 3 shirts. So that also means that I can represent the number of shirts I have using the expression 3Y. All right. I want you to consider or think about that for a second. Make sure I'm not losing you along the way. And then let's take a look at the pants. Same thing for the pants. We said, okay, I'm going to use a Z to represent all the pants. But I want to make sure I'm specific about the number of pants that I have. So I have 4. Well, 1, 2, 3, 4, 5. I have 5 pants. So I missed one. So I have 5 pants. So I need to have 5Z. Okay, 5Z, 5 pants. All right. So that's how we sort in math. We like to combine the things that are alike. We like to bring them all together and make sure we're counting them all up. Why is that important? Well, because when you do your exam, they're going to ask you to do something called simplifying. And we already established that there's different ways to simplify. And one of those ways is by combining the things that are alike. So let's take a look at some examples of simplifying expressions, all right? And these questions are very similar to the ones that are on your examinations. So I want you to take a look with me, all right? So this one I pulled exactly from the exam as it is. So we have 3x plus 8x minus 12x. Okay, awesome, no problem. So let's go ahead and see, how do we simplify? Well, we can simplify a couple of ways. And specifically, we're talking about combining like terms. Now, how do I know that they're like terms? How do I know that they're alike, that they can actually be combined? Well, remember in our earlier slide, I'm going to put it back up for you. We said that, let's go back. Yeah. So the hats are represented by the X and the shirts are represented by the Y. That's how I know that they're alike, if they have the same variable. And we'll learn a little bit more about those variables in a second. But with that being said, let's see if these are like terms. Well, the variable here in this term, the 3x, the variable is X. Okay. Are there any more X's? Well, the answer is yeah, I have an X here and I have an X here. All right, now pay attention to this for a second. So if they all have the same variable, are they all alike? Well, in this case, they all have the same variable, but also notice that they also, all of them have the same, well, in this case, they don't have any exponents shown. I put those little circles there. They're not supposed to be zeros, but they're just circles there to show that the exponent on top of them, there's no exponent on any of them. So that means they're all the same. So, and that's going to come into play a little bit later. But let's go ahead and do the math. Now, if you recall, there is an order of operations that we like to work with. So if I see multiple operations in an expression or an equation or whatever it might be, there's a preferred order. And that's where we talk about PEMDAS. Some of you may have heard of another one called BODMAS, but we're not going to go into too much about order of operations because there's a video on my channel about order of operations that you can check out if you're not sure. But in this case, the last part of PEMDAS says A and S, which is addition and subtraction. So we prefer addition to subtraction. Some of you say from left to right. Either way, it is what it is. So let's go ahead and add first and then go ahead and subtract. Now, like I said, there's more in-depth conversation and explanation about PEMDAS in that video, about what do I mean by, okay, addition and subtraction versus left to right, right? We're going to clarify that in that video. So let's keep going. So we're going to add first. And so we have the 3x plus 8x. Now, I want you to think of this as if I'm saying I have 3 pants or 3 hats, and I'm adding 8 more hats. All right, because the X represents the number of hats that I have, or whatever item you want, marbles, candies, ice cream cones, whatever it is. The point is the X is just representing an item. So I just have 3 of those items. So 3X means I have 3 hats and I'm adding 8 hats to it. So I have 11 hats in total. So 11X. And I'm going to make sure I bring down that 12X because I didn't do anything with it as yet. And now I'm subtracting 12 hats from the 11 hats. That's kind of interesting. How can I subtract more hats than I actually have? Well, let's consider that for a second. If you're going to a store and you want to buy something and they say it costs you $11 or $12 or whatever it is, but you only have 11, what you'll probably do is you'll say, okay, I have 11. You probably will go home because you don't have the money for it. But if you have a friend that you know have money, you'll probably say, okay, I have $11 and I'll borrow $1 from my friend. And so when we're talking about subtracting numbers that are larger, then I want you to think of it as, okay, whatever I don't have, I have to borrow the rest. Okay. So with that being said, I have 11 and I'm subtracting 12. So that means I'm going to end up with -1 hats, or I'm going to end up owing someone a hat. Another way you can do this is by saying negative x, okay? Because the one, you don't have to put the one if it's one hat. You can just say, okay, I just have a hat. All right. So let's keep going and see some more examples of this. All right. So we have simplifying expressions, and we have another expression here. But remember, we're combining like terms. So let's look at the like terms, and we determine the terms based on the variable. And there's another piece that's going to come in the next question that has to do with the exponent. But let's focus on the variable for now. So we have an x here, and we have an x here. All right, perfect. So now we can consider those two terms, whether or not they can be combined, or how, based on the variable. So now, if I take a look at them, notice that both of them, neither of them have any type of exponent there. So the assumption is that the exponent is a 1. So they have the same variable, so I can combine them. So how do I do that? Well, I have 4 hats. And remember earlier I said that the sign matters. The sign that's in front of the term matters. So I'm subtracting 2 hats. All right. And then let's take a look at another group. I have y's in here. So I have a y here and a y here. And so they are like terms based on their variable that's there. All right. And so I can say, okay, I have plus 7 shirts, and I'm adding another 3 shirts. All right. So what do I have in total? If I have 4 hats and I'm subtracting 2 of them, then I'll have 2 hats left. And then I'm adding to that, I have 7 shirts, and I'm adding 3 more shirts. So I have 10 shirts in total. All right. So this is going to be how I simplify the expression. Now, some of the confusion that may come is that you might wonder, well, or better yet, I've seen some students where they'll put y equals something, or they feel like they have to have an equal sign in their answer. And so the confusion can be, okay, how do I know when I'm solving for, when I need one number in my answer versus a letter? How do I know? Well, this is where the difference between an expression and an equation comes in. And this is something I didn't say earlier, but whenever you have an equal sign and maybe another expression or a number, let's say 2x over here, an equal sign tells the difference between an expression and an equation. And an equation is 2 equivalent expressions, okay? In other words, you'll have an expression on one side of your equal sign and an expression on the other side of your equal sign. And we'll talk about solving equations in another session. But when you're dealing with simplifying expressions, all you're doing is combining like terms, getting rid of parentheses where you can. If you see that you can add or subtract or multiply and divide, you're trying to apply as many of the operations as you possibly can based on the expression given. And so if you take a look at my answer for a second, I have 2x plus 10y. If you're wondering, am I done? Is this it? The answer is yes. And how do I know? The way you know that you're done when it comes to simplifying expressions is asking yourself, can I combine anything else? Are there any more like terms here? And if you look at this, what I have 2x. In other words, I have 2 hats, and I have 10 shirts. Hats and shirts are not the same, my friend. So no, I can't combine them. And so I'm done. That's how I know that I'm done. And if you're not sure, go and ask your teacher. Say, okay, I did all the steps. I just want to know, okay, am I done? Is this what you're expecting of me? I'm hoping your teacher's not going to be like, get out of my face, I'm tired. Like, no, I hope not. If that's your experience, I'm so sorry. But for the most part, if you ask your teacher, more than likely they'll say yes or no. Okay. All right. And the last thing is this. I wanted to show you this because you might see this in an exam and wonder the same thing. So earlier we said, okay, based on the variable, that's an indicator of whether or not they're like terms. So let's look at all the variables and see, are there any variances? Is there anything different that I need to consider as well? So I have an x here, I have an x here, and I have an x here. All right. Now, are they all like terms? Some of you might say, yeah, they're like terms. But I want you to take a look at what I also showed you earlier. I want you to look and see, are there any exponents involved? All right. Because the exponent also plays a part. The exponent on the variable plays a part in whether or not they are like terms. All right. So here we go. If you notice the first term, which is the 6x to the power of 2, that's the only term that has an x with a power of 2 on it. So that term is not the same as the x's that do not have a power of 2 on it. All right. So what does that mean? And you can replay that again if I confused you a little bit. But what that means is that the only two like terms among the x's would be the 4x and the 5x, because they both are they only have an x. But the first term, which is 6x squared, that's going to be different. All right. So with that being said, let's go ahead and combine our like terms. So we have the 6x squared. Because there are no like terms to that one, I am just going to write it back. I can't do anything with it. All right. And if you cannot do something with a term, you just rewrite it and you're good. All right, so now 4x, so like 4 hats plus 5 hats is like having 9 hats. So 9 hats. Perfect. All right. Now let's take a look at the 7 and the minus 6 for a moment. So we have a plus 7 and we have a minus 6. Now the question might be, are they like terms? Well, these two numbers would be considered constants. All right. Constants, remember, they are numbers that do not have a variable attached to them, do not have a letter. So 7 minus 6 is literally just 7 subtract or take away or minus 6, which is just going to give you 1, specifically a positive 1. And so this is our final answer, right? There's no necessarily any equal. I have a lot of, I have more terms, but it's simpler than where I started off. And if you look at it, I have no more like terms, so I can't combine anything else. And so I'm done. I'm all done. All right. So yeah, that's how you simplify expressions now using combining like terms. All right. But what about this? What about if I have parentheses involved? What do I do? What do I do with parentheses? And that's where we get into what we call the distributive property. So we talked about combining like terms, and I want to talk to you about the distributive property for a second. All right. And this is just what the distributive property says. The distributive property says, if I have something that looks like this thing right here, which is 2 on the outside, or a number on the outside of the parentheses, and it's being multiplied by 2 things or 2 or more things being added, we call these the addends, then I get the same result in my calculator as if I simply took that 2 and multiplied it by the first number and added that product or that result to the same 2 multiplied by the other item. And it doesn't matter how many things you have in those parentheses, the rule is still the same. Now, if that kind of got you lost a little bit there, let's actually practice it so it makes sense, okay? And generally speaking, most math, it makes more sense the more you engage with it, the more you practice it, okay? So practicing is going to be really important. So let's take a look at what I said and how the distributive property works for this example. We said, okay, if I have 2 or a number outside, doesn't have to be 2, it could be any number really. If I have a number outside of my parentheses and it's being multiplied by a group of things being added together, then the result or the final answer is the same as if I simply took this 2 and multiplied it by everything. So if I took this 2 and multiplied it by the x, and then add that result to 2 multiplied by the 3. All right, so let's write that out for a second. That would be 2, positive 2, keep in mind the signs matter, times an x, and I would add that to the positive 2 times the positive 3. All right, so that's what distributive property is. Now, let's do the multiplication. 2 times x is literally like me having 2 times, and x represents shirts if we want, but 2 shirts. So that just gives me exactly 2 shirts, so 2x. I don't have to put the parentheses anymore. And then I add to that 2 times 3, which is going to give me a positive 6. And this would be my final answer. All right. How do I know? Well, I have no more like terms. I can't combine the 6 with the 2 because the 6 does not have a variable of x. They don't have the same variable. And so I can't do that. Excuse me. Sorry. All right. Let's take a look at another example. Here we go. We have some negatives in here. Now, some of you get a little bit nervous when we see negatives, but let's just take our time and do what the rule says to do. All right. So our rule says if I have an item on the outside of my parentheses and it's being multiplied by items inside parentheses, and notice there's a subtraction there, but it's okay. The rule is still the same. I am going to do the same thing. I'm going to multiply that negative 3 by everything inside my parentheses and just add their results together. So let's write it out. I have negative 3 times 2x. I'm going to add that to negative 3 times, and remember, signs always matter in math, okay? They always matter. So it's actually going to be negative 3 times a negative 1, all right? And the reason is because that's a negative sign in front of the 1. I don't want you to forget that, okay? So let's keep going. Let's actually do the math now. So what do we have? Okay, so we have a negative times a positive, right? Now, what I want you to remember is that whenever I'm multiplying a negative number by a positive number, my result, my answer is going to have a negative sign in front of it. We'll talk more about that later, but it's going to have a negative sign in front of it. So here we go. That's going to be, so our answer is going to be negative. Okay, so now that we took care of the signs, we're just going to look at the individual numbers now, okay? We're not going to worry about the sign because we know that the sign is negative. Now, what is 3 times 2x? Well, that's the same as saying I have 2 shirts and I'm multiplying that by 3. So now I have 6 shirts, or 6x. So I have 6x. And then now let's take a look at the negative 3 times the negative 1. Negative 3 times negative 1. So we're multiplying 2 negative numbers. And if I'm multiplying 2 negative numbers, my result is going to be positive. If you were thinking negative, it's positive. And you can check out my video when it talks about multiplying and dividing real numbers, okay? And adding and subtracting them. But when you're multiplying negative numbers or an even number of negatives, the result is going to be positive. So I'm going to have a positive 3. And this is my final answer. How do I know? How do I know I'm all done? Well, notice that this first term has a variable of x, and this second term is a constant. It does not have any variables. So we're all done. We're all done, okay? So let's keep going. I want you to try this one on your own. Try this one on your own, and you can pause the video here and try it. And then I'm going to keep going, okay? But you can pause it, try it, and then compare your answer to mine at the end. So here we have a combination of things going on. We see that we have parentheses, which is an indicator for me that, something's going on there. And specifically, I have a number or a term in front that's being multiplied by terms inside that parentheses that are, experiencing a number of operations between one another. So I'm going to do the distributive property, which says I'm going to multiply the 2m by each item inside my parentheses 1 by 1. Now, the more you do this, for some of you, you can do this in your sleep, and that's really good. But like I said, I'm dealing with students that some might not know, and some might not be sure. And so I have to make sure, I want to make sure I fill that gap in before I move forward. So here we have 2m times a negative 4m, and we're going to add that result to 2m times 6. All right, now we're not done, because notice that at the back I have a minus 10m. We don't want to forget other terms that exist in the problem just because we're not doing distributive property with them. All right, so whatever you haven't done or haven't touched in your steps, you can go ahead and rewrite it. Okay, we don't want to forget anything as we're going forward. So now let's do the multiplication. We have a 2m times a negative 4m. All right, so what does that mean? let's take a look at the numbers first, and then we'll talk about the variables and how they work with one another. So we have 2 times negative 4. So we're doing the numbers first. So 2 times the negative 4. So that will give us is it negative or positive? It's going to be a negative 8. So negative 8. And then we have m times m. So m times m. Notice we're not adding m to each other. We're multiplying them to one another. So when we're multiplying m times m, so m times m, what I want you to note is that the answer is actually m squared. All right. So we introduce exponents when we see a repetition of multiplication with the same base or the same number, in this case the same variable, then we introduce exponents. So let's take a look at that. All right, so our answer would be m times m would give us m squared. All right, m times m. If it was m plus m, then you have 2m, but if it's m times m, it's m squared. All right, and now the next part of it is we have the 2m times 6. That's what we're going to do next, and that gives us 12m, so plus 12m. And then the minus 10m here is what's going to come down, so minus 10m. All right, awesome. So now that we're there, let's take a look at if we need to do anything else. Well, are there like terms? If your answer is no, then you need to rewind this video, okay, and look at it one more time. But if your answer is yes, then you would be correct. You're on the right track. All right. So, what are the like terms? Well, we notice that all of our terms have an m in it, but looking very closely, one of these m's has a square on it. And so the one that has the square would be the one that's like the oddball out. That will not be a part of the combination of the other terms because it has a square. So that makes it stand out, okay? So I'm going to go ahead and write the negative 8m squared back because I can't do anything with that. But what I can do is I can combine the 12m minus the 10m. So 12m, or 12, whether you want to do shirts or something, or zips, minus 10 of them will give me 2. So a plus 2m. All right, there you go. And so this is your final answer here. How do you know you're done? How do you know? Well, what you're going to do is you check the variables and you see if they have exponents. And if they do, and the exponents are different, then they can't go any further. And in this case, we cannot go any further than this. So we're almost done. We're almost done. I want you to try this one on your own. Okay, and the next time we come back on Tuesday at 5 o'clock, we're going to pick up here and we're going to keep going. It's going to be, it's about an hour now. Wow, time just goes by so quickly. But we were able to go through combining like terms. We talked about vocabulary first, then we talked about combining like terms, and we're done with distributive property for now. All right. But this example, you can take a screenshot of it. You can write it down. I want you to try it. Come back on Tuesday. We'll pick up from there and we'll go further. Okay. Now, what's next? What can you expect for Tuesday's session? Well, we're going to talk more about simplifying when you're dealing with division. So we did simplifying when you have add, subtract, and multiplying. We did distributive property. But what about division? What do we do there? Right? And then we also have to talk a little bit about our order of operations. And then something that kicks our butts almost all the time in exams are word problems, right? If someone gives you a very clear equation or expression, they say 2 plus 2, oh, you can find the answer. But if they say, oh, the sum of x and 9, all of a sudden we're lost. So I want us to talk about that on Tuesday. Okay, so if word problems kick your butt, come and tune in. And what you can do as well, you can type in the chat whatever issues you happen to have with word problems. I'll read your comments, I'll read your questions, and I'll address them the next time we come on, okay? But I want to make sure I leave you with a tip for when you are studying, something you can literally do now, tonight, tomorrow, every day, that will help you to really retain a lot of the information you're learning when you're studying, okay? So here's a tip. Now, I told you that there's 8 sessions, so I'm going to do one every night. I'm going to just do from number 8, and I'm going to do my number 1. Well, yeah, I'm going to do one every night. So number 8 tip, and this isn't necessarily in any order. I should have just put number 1, but I didn't want to put number 1, making you think that is the number 1, because it's not. It's just one of the top ones that I chose. So break your study time. Break up your study time, all right? So if you say to yourself, okay, I want to study for 1 hour, I want to give you an example of what's going to be most effective for you. Now, if you can do an hour straight, then do it, especially if it's something you're really passionate about. I used to be really passionate, I still am, passionate about math. And so I can literally sit down and study like for fun. I would do equations. Like, people don't do that. But if you have a topic that you're super excited about, and an hour is like nothing for you, go ahead, you do your thing. But if you have a challenge with studying a topic, it's very helpful to break your session up. If you say, okay, I want to study for an hour, then here's an example. You can take 1 hour and you can break them down into 2 30-minute sessions or 3 20-minute sessions. And in between those sessions, you'll take the first, what you'll do is you'll say, okay, what do I want to learn how to do? Okay, I want to learn how to solve 2-step equations. Okay, no problem. Okay, so that's your goal. So what you'll do is in the first session, and let's say that's your goal for the first session, then what you'll do is you'll find an example of that problem, and then you'll do maybe 3 or 4 practice problems of it in the first 20 minutes. And then you'll take a 3 to 5 minute break, or 5 to 10 minutes. Do not go and take a nap unless you really have to. Your break doesn't have to take that long. Your mind doesn't need that much time to recuperate. All you're doing is going to go out, maybe take some fresh air, a short walk or something, take a drink of water or something like that. But just a short break, and then come back. All right. And do another 20 minutes. You might say, okay, I want to learn how to evaluate expressions. And so that's what you do for that next 20 minutes. And okay, perfect. I got that done. And then you go take another little break, and you come back for the last 20 minutes and you say, okay, I want to learn how to do distributive property. Oh, no problem. And you go and you do a couple problems of distributive property for the next 20 minutes. And there you have it. You have 1 hour broken up into 20-minute sessions, or like I said, you can do 2 30-minute sessions as well. But breaking it up will help your mind, okay? Let me be very clear. If you find yourself falling asleep when you're studying, it's very unproductive. You're not going to retain it. Even if you're forcing yourself to stay awake, you're not going to remember. You're just not going to remember. So the most effective way, if you're going to study, and literally you can practice this tonight. If you're going to study, go ahead. And if you find yourself like drifting off, stop. Go and take a nap or go and take a walk and come back refreshed and ready to go. Now, some of you have a problem. As soon as you hear math, you fall asleep. Okay, that's a problem. So what you might need to do is take a break, or take your study habit or study spot to another area. And we're going to talk about that tomorrow. But yeah, break your study up, okay? That's where you're going to be most effective. And just set goals for each of those times. So if it's 30 minutes, set a goal. And when you've accomplished that goal, go take a break and come on back, okay? But yeah, you've made it to the end of our time together. 1 hour, not too long. But like I said, whenever you get tired while we're watching the video or something like that, just pause. It's recorded. All right, just pause it. Take a break and come on back. But I just want to let you know, I believe in you. I'm so excited. I want you to go back and rewatch it. And I want you to try some problems on it. What you can do, I'm going to have some like practice, like worksheets for you guys, links in the chat as soon as this is done, the live is done. But I want you to go ahead and try some practice problems. Try simplifying using combined like terms. Try doing distributive property, and then try doing both, okay? I want you to try to identify the variables in an expression, and try to identify the terms and the constants and the coefficients and all that stuff, right? A lot of words, a lot of vocabulary words, a lot of information, but thank you for joining. I'm so excited. I'll see you on Tuesday at 5 o'clock, okay? Like, share, subscribe, and make sure you bring a friend. And one of the biggest things that helps you to really retain information is by finding someone to teach. So that's your challenge. Go and find someone to teach what you learned tonight, and practice, practice, practice. I'll see you on Tuesday. Bye.